As you can see, we're going to do experiment 2 here, the physical separation of mixtures. Please make a note in your report sheet that this is mixture A, like you see on the bottle. There are 3 components. You can also see that on the label: ammonium chloride, sand, and sodium chloride. Okay, so first step is to weigh out a bit of the sample. Notice you always want to tear the balance, it zeroes out the balance, and then make sure that when you do make a measurement that you keep all the doors closed. Okay, so there's the mass of the empty evaporating dish. Adding a little bit of the sample. What I'm doing here is just approximating the mass of it right now, and then I'll go back and remass the sample in just a minute. But there's your mass that you want to record for the evaporating dish plus the mixture. So here's the setup. We've got the clay triangle going to be placed on an iron ring. It's above the burner. There's the evaporating dish with our sample, just that we saw just a minute ago. Here I'm opening the gas valve on the bottom of the burner, lighting it, and now I'm opening the air control for the burner. When you see that light blue inner cone on a Bunsen burner, that indicates that the burner is properly adjusted and you have the proper gas to air ratio, giving you a non-luminous flame that's nice and hot. And we'll place that under the evaporating dish, and we'll watch the reaction. Okay, you're starting to see that is not steam that you see there. That's actually a solid that is subliming out of the sample. It's the ammonium chloride sample. And I'm doing this in the hood because it's never a good idea to breathe in fumes like that. And as it heats up more, you'll see that the white looks like smoke is going to increase. The amount of that white powder is going to increase. The other 2 samples in the mixture are sand, silicon oxide, and sodium chloride. And neither of those samples sublime at Bunsen burner temperatures, nor do they melt. And so they're relatively stable in this system. So really, this first step, we're only removing the ammonium chloride from the mixture. And I'm going to speed up the video here, so because this takes a while. So what I'm doing here is just mixing up the sample. And one thing you notice that the sublimation has increased, so there's some ammonium chloride that's sort of trapped in the solid mixture. And when you mix it up like that, it allows it to sublime more easily. Speeds up the reaction. Again, that is not smoke. That is solid subliming due to the heat, the solid, again, ammonium chloride. And that white powder that you see on the glass stir rod is ammonium chloride. And so what's happening is that the solid ammonium chloride is subliming in the sample, and then that's the white powder, the white smoke that you see coming out of the evaporating dish. And then it's depositing on the cold glass stir rod. And so all that white that you see on the glass stir rod is ammonium chloride coming out of the sample. And again, I'm going to speed the video up now. And notice with the stirring, it's practically now, there's no sublimation occurring out of the sample. That tells us that all of the ammonium chloride has sublimed. So now we only have sodium chloride and sand in the mixture at this point. So I turned off the burner, cooled the evaporating dish, and now I'm adding the distilled water into the sample. So again, sodium chloride, common table salt, and sand. So what's happening here is the water is going to dissolve the sodium chloride, and that does the final separation step in the reaction. And so, just to get a good separation here, I'm going to stir the sample so that the bulk of the sodium chloride will dissolve. And then what you're going to see is that since the sand is a solid, it's what we call a suspension. That solid settles to the bottom of the evaporating dish. And so I can simply just decant or pour off the water into a clean beaker. So now that water that I'm pouring off, it's actually not just water. It's a sodium chloride solution at that point. So again, the sodium chloride is going into the water phase, aqueous phase, and then the sand is remaining in the evaporating dish. And as it turns out, when you're washing or extracting a compound with a liquid like that, it's best to do it multiple times. So the bulk of the sodium chloride, I'm sure, came out in that first extraction. But then at each subsequent extraction, I get a little bit more. And I think I do it about 5 times to get the bulk of the sodium chloride out. And again, I'm going to fast forward the video. Okay, so I have my sodium chloride in the water. I have the sand. It's a wet sand in the evaporating dish. So I need to set up my Bunsen burner again. Same deal. Clay triangle is going to support the evaporating dish. The Bunsen burner's already been adjusted, so I don't need to do anything. I just got to turn the main gas valve on. And it's pretty much ready to go. Yeah, so here you can see the inner light blue cone and just how aggressive the heating is for this step of the reaction. And again, all we're doing here is driving off the water. and there's the mass of the evaporating dish and the sand. This will be used in part C of the experiment. So there's the solution of water and sodium chloride. That's what washed out of the mixture. After the sublimation of the ammonium chloride. And all I'm going to do here is put it back into the evaporating dish and heat it to dryness. So if you look at part D of this lab, there's actually two different options that you can do to figure out what the mass of sodium chloride is going to be. I'm using option 2. Okay, so at the end of this, the sample will be dry and it'll just look like it'll be salt. It'll be a white solid in there. So what you're seeing there is the evaporating dish with the solid sodium chloride in it. That's the white solid you see around the sides of the dish. And there's the total mass of the two. You'll use that mass in part D of the report sheet to then calculate the mass and percent of sodium chloride in your sample. And that's it.